Hi, welcome everybody. This is Ashish Agrawal, one of the product managers in Oracle development. Today I'm going to talk about extreme Exadata top 10 analytics technique to maximize performance. Uh, to begin with, safe harbor statement, I'll give you a minute to read, a couple of seconds to read. I have to have it for legal reasons. Nothing to worry here. Okay, so this is my agenda. What is analytics? We'll briefly touch base on it. I will describe the problem statement I want to solve. Then I will also describe the Exadata management challenges. And then I will go through the top 10 techniques that can help you to maximize the Exadata performance. So what's analytics? Basically, it's a discovery of first the meaningful patterns in the data and then ability to communicate it also. For example, how many crimes law enforcement have detected over years to date by certain categories and by week to date, or how was the traffic visits via my 10 campaigns in last certain months, or uh, demographic information like sales by a customer location across the world. So those are some of the examples of what is an analytics in a very simplest form. So that's what exactly we are going to do when I talk about Exadata performance. So in your data, what kind of patterns I see, that's my goal here. So my problem statement is, why this analytics is needed. So the current tools today focus on monitoring and diagnostics of your IT assets like databases or middleware, or in this case, it happens to be the Exadata one at a time. So you may have three, four, five, six, seven, or maybe more Exadatas. You may lack insights across your entire data centers, and you may be running hundreds of databases on top of these Exadatas, right? So how do you identify a pattern of problems over large historical time periods across your entire data center? And because we are just monitoring today, we are not able to do analytics like correlation, trending, and forecasting, because this requires either some kind of statistical analysis or a machine learning capability, which again requires horsepower to run out of the box. So that's my problem statement. And in relation to Exadata management challenges, very specifically as Exadata administrator, IT administrator, or Exadata manager, or the planner, capacity planner, you would want to know what are your resource bottlenecks. Do you have enough capacity? Or based on your current load growth for existing databases, when I am going to bottleneck, do I have enough capacity, or which workload, which databases are responsible for highest resource growth consumption? On other hand side, from performance perspective, you would want to know which are your best performing SQLs and which are your worst performing SQLs, both at the same time, right? Or is your SQLs regress due to bad plans versus just simply excessive weights for some underlying root cause? Like, the IO weights, are they coming from disk or flash storage subsystem? And then if you are looking to do capacity planning so that you can onboard more and more workloads to your Exadata, do they have enough capacity to support that kind of consolidation? And how can other questions you should be able to answer is, does my flash disk and my disk resources have enough capacity, both physically as well as in terms of IO and throughput? So can we answer these questions out of the box systemically across fleet of databases, not one at a time, but over a historical period of time? So those are the questions that my techniques will help you to answer. So here are the top 10 techniques basically. First, get a unified view of your enterprise-wide Exadata estate. So when I say a unified view, you should have a dashboard, a single dashboard, or an application where you first get your inventory, your resource usage, the current resource usage, your available capacity, and any databases that may have performance issues, errors, alerts, and status of each of your Exadata at any given point of time and in an automated fashion. Okay, so that will help you to keep a bird's eye view on your entire Exadata estate. So this is a very basic, very fundamental technique to get, the best out of your Exadata. So what as an app we provide is one, the global resource usage, any databases that are degrading in performance, the inventory of databases and the databases on Exadata. And it will out of the box tell you what are the highly utilized Exadata, and at the same time it also answers the question which Exadatas are available for database consolidation, because currently they are lowly utilized. So what's the benefit of doing this? It actually helps us with the operational challenges in the areas of resource performance, capacity, and errors, because whenever you log in, you get this information in an automated fashion. The second challenge that the second really my tip is pinpoint Exadata systems proactively that are going to run out of resources in a short term. Okay, the benefit of it is really it gives you lead time to take corrective action, and it should be done again in automated fashion based on your historical usage. So to do that, you would need machine learning, and very specifically 4 key resources in terms of Exadata: your compute node CPU, compute node memory, and Exadata storage server IOPS, and the physical space. As long as you do that, you are very well covered in terms of your capacity aspects, and that would not lead to any performance problem. And at the same time, you should be able to identify what are your top growing databases and which SQLs are consuming the highest resource across your entire Exadata estate, not just one single database, but across your entire database, entire Exadata estate. So we do have an out of the box app that solves this problem. If you look, I have taken a screenshot, and time permits, I'll go through the demo also little later on, that we out of the box project any Exadata systems that are going to reach a capacity thresholds like 75% between 0 to 30 days. You see here between 0 to 30 days. And on the other hand, right hand side, I have a system which has enough capacity to last for 180 days as well. So those kinds of insights, like for the current resource utilization as well as for the future, if you get that, you are likely to get better performance. You because of any capacity issues, it gives you lead time. So that was my second tip. Third tip is identify Exadata systems with low utilization. So 2 use cases. One, it of course if you're using something very low, then you should be optimizing that resource utilization. That can be done by onboarding new systems. And second thing, if you know which systems are not lowly utilized, that means you should not buy more. Okay, so that's why uncovering any underutilized capacity helps you. And again, that should be based on some kind of machine learning or statistical forecast. And that's what exactly we do. We project out of the box, hey, this Exadata system is not going to use more than 25% for the next 6 months. based on host CPU, uh, uh, host memory, IOPS, Exadata storage server IOPS, and the physical space that's available on the Exadata storage server. So that means that Exadata is really a candidate where you can onboard more databases and more workload. And that helps you to save money also, preventing you to from overbuying anything. So that's my third tip, because that will help you to rebalance also. Okay. Then the fourth tip is forecast your resource requirement versus your headroom. Every customer, every environment has a unique requirements in terms of performance, SLAs, and objectives. So if I define a headroom, I must know with respect to that headroom how much capacity is available. And after a certain period of time, let's say 30 days, 90 days, or even 365 days, do I have enough capacity left so that I can meet my SLAs? So we do out of the box do forecast on the four resources: CPU, memory of the compute nodes, IOPS of the Exadata storage server, soft storage server, and the physical space. And it's based on a machine learning. Also, we take care of the seasonality, and you should also keep in mind about your seasonality of your workload, when the weekly peaks happen, when the daily peaks happen, and also able to identify if there is some repeating resource patterns. So based on that, by default, we have set our headroom as 75%, and we can do forecast out of the box and make you more proactive. So that can help you to do capacity planning and provide a lead time to take a corrective action. This corrective action may be tuning your workload, because if your resources are used because some SQL is running bad or some database is running bad, that's the first option. You should exhaust that option. Second option, if that is already done, can you do workload rebalancing? Meaning, if a system is overutilized and if you have another system that is lowly utilized or utilized on an average way, can you move some workload out of it and put it on another system? And if you have done all the above too, and still you have forecasted growth, because you know your business is growing, which is a great situation to be in, you need to plan for additional resources. So that's where the forecast, the four type of resource requirement versus headroom comes into picture. The fifth one, I was touching base on the performance earlier. So you should keep an eye in an automated way across your fleet of databases, which ones are performing good, which ones are degrading, which ones are not performing efficiently, where there is more opportunity of improving performance. You may be getting an acceptable performance, but that does not mean you cannot get more out of it. And also workloads which are varying in performance. So how does this help? Let's say your data is growing, which is very common now, right? I mean, because data explosion is happening, and even your best possible return application can slowly degrade over a period of time, because you're scanning more data blocks, either via indexes or via full table scan that's happening on the Exadata storage server, right? So as the data grows, at some point of time, the responses for even better tuned application SQLs may not be as expected. So how can I keep an eye on those kind of scenarios in an automated way across my fleet of databases? We do have a database performance analytics app that does that based on a linear regression and activity and response time. It goes and does a linear regression and identifies databases that are degrading over the period of time. The second use case here is about databases not performing efficiently, meaning there are excessive weights in compared to CPU and IO usage. So such weights are needless. We should try to minimize these kind of weight events. So out of the box, I recommend you identify such scenarios that can tell you which workloads you have an opportunity to do more application tuning that can lead to better performance. So if we do follow this tip, it will help you to maximize the performance and improve the application performance. The sixth tip here is really to identify any SQL issues so that you can really avoid problems, performance problems proactively. So what are the use cases? Some of the use cases that I can solve here is identify, the tip here is to identify any degrading SQL. That's the first one, based on response time. The second one is the variant SQL. When I say variant SQL, meaning sometimes the SQLs are returning results in uh, 2 seconds, sometimes in 4 seconds, sometimes in 8 seconds. So that's varying. Or a bad job returning results in 4 minutes versus 6 minutes versus 8 minutes. So we expect a pretty stable response time of the workloads. We should be able to identify such scenarios so that our performance is expected. Inefficient SQLs, these are the SQLs where the SQLs are needlessly waiting on non-CPU, non-IO wait events. Uh, we as long as we are able to minimize such waits, we will get better response times from our workload. And the fourth one, as a DBA and a developer or a DevOps team, we always want the plans to be stable. Uh, for various reasons, they should not be too volatile in nature. So out of the box, if we track SQL with plan changes, that can make our life simpler to give better performance. So what the app does is it tracks the performance of a SQL over a period of time. If it slows down over a period of time for whatever underlying reason, either because of a plan change or optimizer statistics or some changes in the underlying object like an unusable index or index not present, or simply because the data has grown, it needs partitioning or it needs some kind of in-memory usage, we are able to track such scenarios based on linear regression and tell out of the box, say, focus on this SQL proactively. So that can help you to maximize performance. Then the top SQL by CPUs, again, we typically from AWR and Ash, you can get real-time information about a single target, and maybe for 1 hour or 1 day or maybe 7 days typically, which are your top SQLs. But again, that's by one target. What if you're running 100 databases or 50 databases or even 20 databases on your Exadata? Hard to find. Somebody has to either go manually and find it out. So this is probably the best way. What are your top SQLs by CPU across your Exadata estate? If you come here on this portal, log in and see, you will get. So that helps you to focus on a particular type of workload, particular SQLs, so you can keep an eye on it. And if needed, you can tune it. And another important aspect that I recommend is compare your performance trends across your dev, test, and production environments. Again, we can do it manually. It's harder. If you can do it in the same console in an automated fashion that happens automatically, that can help you to get better performance. So this way, you will become more proactive. Okay. Now, we should always analyze performance. Now, Exadata is a very precious piece. Typically, a lot of us customers and all of us runs, multiple databases on the same Exadata. So Exadata is basically a platform where you share, multiple workloads. Now that brings additional challenges. Some workloads may probably try to use all of the available CPUs and IOs, possibly. So how do you kind of, identify those situations and try to justify and give, not, of course, there are DB resource management and other techniques, IORM and other techniques, but how do you really identify which ones are getting impacted and which ones need what, right? So, and that too over a long period of time, based on the data over a long period of time. So my tip is, looking at this application, you should be able to identify the long-term trends of your databases running on a single Exadata, compare the DB CPU utilization, memory utilization, and IO growth rates, including the breakdown of IO per second and MB per second, and as well as the storage requirements. And then this can help you to set your DBRM and IORM based on long-term data, and help you to consolidate databases as well. So if you look on the right hand side, we do identify growth rates of databases, and as well as MB per second. And then there is an ability to compare IO as well as CPU in our DB resource analytics that's available out of the box. Now the eighth tip I have is to identify your compute node utilization, storage cell utilization, as well as identify outliers based on, this is basic, but this will help you. If you keep this in mind, this will help us. Based on, certain metrics, I have identified those metrics. So first of all, any CPU bound compute node should be identified, or even if you're leading towards this CPU bound workloads, we should know that out of the box immediately. Similarly, we should keep an eye on memory utilization of our DB nodes. And then for the storage cells which are approaching the max performance capacity based on IOPS and MBPS, should be identified, and any outliers in any of the storage cells should be pinpointed out. So that this actually, if you identify, this may lead you to the systemic cause of the problem and help you to fix that and impact all the workloads running on this Exadata. So that's why this is an important aspect. This is very basic, but it will help you to get better performance out of the Exadata box. The ninth one is a little different. That's basically using a logs approach to keep an eye on your errors, DB errors or storage errors, or even your application errors, or your syslogs. So our recommendation is, my tip is basically have a centralized location where there is automatic collection of these database logs and they are analyzed. For example, out of the memory deadlocks or ASM disk errors. Because as long as we get a proactive analysis and notification, rather than we spending time of doing all the collection and analysis, if it happens automatically across the fleet of databases, including your application, that will benefit out you more to get better performance. Because more the errors we avoid, errors are no matter going to happen in a real world environment for various reasons, because of complexity of workload or changes to the application or to the storage system, or even for failure out of some failure in the DB side or the storage side or the hardware, whether it is permanent or intermittent. Okay, so for those kind of scenarios, if we can do analysis of logs have millions of entries, and they are now they grow in couple of GBs every day. So it's simply humanly it's not possible to do analysis. Better to rely on some automated system that does the collection and analysis and maybe alert also. So if you have such capability, that can help you. That's my tip number 9. And the 10th tip is really use machine learning. So as I mentioned, the logs can be of GBs to terabytes very easily in the current real world scenario. So use machine learning. The logs typically have a same signature for same type of component. So use some technique like clustering, which can reduce the size of your uh, target data set and pinpoint anomalies in that. So basically identify the same repetitive signature and pinpoint anomalies that can help you. And the second tip here is compare two clusters of logs that can very effectively help with the troubleshooting and reduce your mean time to resolution. So those are my 10 techniques. I will move on to the demo, and before moving on to the demo, a very quick architecture of the Oracle Management Cloud. So on left hand side, this is your data center, and right hand side this is the Oracle Cloud Management, and you can deploy the cloud agents on your Exadata databases. That will pull all the data, and everything else that I have mentioned is done on the management cloud. All the machine learning, all data collection, data storage, analysis, everything happens on the management cloud. And this is available across all the data centers in Europe and Middle East. So give me a moment here. I will quickly go through the demonstration here. So bear with me a moment. All right, so view full screen. All right, so this is, so as you can see, this is my Exadata Analytics app I was talking about. Of course, there are many other features here, but we will strictly talk about Exadata Analytics application here. So I mentioned about inventory. So what it means is I have an inventory of 4 Exadata boxes. It tells me the type of my databases first, whether it is a quarter rack, half rack, or full rack, whether it is virtual or not. That also is analyzed out of the box. Then the second thing is the analysis of databases on these Exadata boxes. Whatever versions and so forth, we will get a histogram of those. Then I mentioned about the resources, right? So first, out of the box, I get the current utilization of my Exadata systems. So what it is saying is I have one system that's currently utilized between 0 to 25. That's based on host CPU, host memory, IOPS, and Exadata storage server space usage. And then on the other hand side, I have one system that's utilizing between 75 to 100%. Okay. Now, forecast. This is where the machine learning comes into picture. It's telling me that one system is going to run over your headroom capacity between 0 to 30 days. On the other hand side, on the right hand side, there is one system that there is enough capacity left. There is no issues based on the past usage. And in this case, the past usage is 90 days. I can do analysis based on last 13 months worth of data. We as a service provide you to give you ability to analyze last 13 months worth of data. Okay. So that's out of the box answer. The third answer I was mentioning, identify systems with low utilization. So out of the box, I'm telling here that out of the four, one Exadata system is lowly utilized. So that's a candidate of, onboarding new systems, or useful for workload rebalancing or starting new projects. The fourth answer I get is global resources. So as a manager, as a director or a VP, if I come and I see, hey, I have 672 cores and I'm using only 31 cores. So why do I need to buy more? Right? Let's try to utilize it more, right? Or justify it why we are only using 31%. So very similarly, we keep an eye on all the four key resources. Now that's and I mentioned about performance insights. So out of the box, we tell you insights to your DB performance. So currently I have 0 databases degrading, which is great news. That's how ideally I should be. Okay, I should have 0 here everywhere. Now the resource insight. So here, if you look, I am for one of my databases, X52, my quarter rack, I am using 82%. So my capacity threshold line is 75%, and that's why it is saying days to reach is 0 days. So basically, this system already has an issue right now. But based on the storage server, I have no issues here. I have 42% left. That is based on my past usage pattern. It will take me to 365 days. So I don't need to buy any Exadata storage server for space reasons. Okay. So now the drill down. So this is the entire dashboard that you get out of the box. And now the drill down. So I am specifically now looking for my X52 based on my 90 days worth of data. Of course, it gives you what is your software inventory and hardware inventory. But key resource insights that we were talking earlier, host CPU, host memory, and IOPS. This particular system is already using 82%. No DBs are degrading in performance, which is a great news. But let's see which databases are contributing to this resource utilization of this compute node CPU. So first, these are the 5 databases with the growth rates. Memory is not an issue, we know that, but these are the 5 databases that are, contributing the memory growth. Storage is also not an issue here, but I get which DBs are contributing to the growth rate of the space usage and what's that usage. And of course, if you click the see all, you go into more details of that. So host, I can see that it is I have 2 compute nodes, and both are currently moving is using more than my threshold right now that I have set for my 36 core per compute node Exadata servers. So bear with me a minute. We'll drill down a little bit more into details of that. And memory, I have no issues. I have capacity left, but certainly one compute node only have 20 days left. So maybe I'll have to pay attention to that as well. Similarly, this Exadata storage server, let me go here. My disk space usage and my IOPS and my throughput. Okay. My throughput does have an issue here, but that should be maximum. So that's great. As long as I don't have a performance issue, that's great. IOPS, no issues here. So let's drill down into the host. So as you can see, it's, now already breaching my capacity headroom line of 75%. So let's go into details of that. So I get to see how my compute nodes are behaving. So this is my 80% threshold. I have changed my threshold to 80% because that was my comfort level, and I can see that it has breached that limit. That's why it is showing 0 right now. Memory, I am close to reaching to that level. That's why I was seeing 20%. I get insights that, hey, Thursday is where my highest CPU utilization day. Okay. Now the forecasting part. Okay. Here I'm forecasting in 90 days in advance because that's the time period I came in right now. On January 1st, my requirement will be 2021. My requirement will be 31 cores. So this gives me the lead time. Here are my my regression models inbuilt. There are 6 regression models inbuilt here. You are welcome to use any of those and do some kind of what if analysis, but out of the box we use the best one. Typically it may be machine learning linear or the linear algorithm. And also the time period, you can do it between 1 to 365 days in advance, basically 1 year in advance. And there is a confidence channel also. So 95% is really a qualitative limit, meaning only 5% of the time it will lie beyond those forecasted range. So this is out of the box, we do the forecast. And then we can also find out which database is perhaps contributing or which workload is contributing. If it is not the database, which workload is really contributing to this. We can go the hosted entity utilization across the host will go. It will take a little bit while to find that. So I can clearly find out, which database is or databases. If it is not just one, I have multiple databases running against this host. So it's probably a group of databases that's causing this issue. So this is one of the use case that I can use it. I can use it, without my uh, without my without an Exadata angles, just as a pure host analysis. I can go and do very similar analysis of the host across my entire Exadata estate and try to answer which hosts are being used more, what's the CPU utilization, what's the forecast, which are lowly utilized systems also, and so forth. And to complete the picture, let me tell you, I was talking about the database performance analytics. So this can help me to identify my databases which are basically having performance issues. So what I'm saying is, out of the 59, 10 have performance issues. And if I pay attention on them, I can, become proactive and get better performance out of my either Exadata boxes, or even if it is on a non-Exadata system, I can get that. And I also spoke about identifying SQL performance problems across your fleet of databases. So the 4 use cases I mentioned in my talk: the degrading SQL, the variant SQL, the inefficient SQL, and SQL with plan changes. So what I'm saying is, out of the 83, 33 are degrading. Let's drill down into it. Let's try to identify if there are any performance, what are the performance issues of those based on historic patterns. So I can see that this particular SQL ID is the most problematic right now across my fleet. So I go and drill down into that and can get typical details of my SQL performance characteristics. So that's what is really my tips for Exadata. I will stop here and open the floor for any question and answer. Thank you very much.
Thank you, Mr. Ashish. Yeah, there is one question in the question and answer.
Yeah, let me go and try to find that here. Okay. Thanks first. You know, is it set up and enabled by default on Exadata system? Does it need a separate license? Is it available for supercluster? How much is the extra load to put the tool by itself? So first, we need to deploy a cloud agent. That's the only piece of software we need to deploy. It's not set up by default. We will have to deploy and enable that. It's a basically a paid service. There is no license requirement, but it's a paid service. It is a paid service. You will have to subscribe to the service. Is it available for supercluster also? It is available for supercluster, but as a generically, you can deploy the cloud agents and get details about the host. Uh, Not as a supercluster, because supercluster may have zones and other things. That's currently not provided out of the box, but as a host, you can get host data, you can get performance of your databases on your supercluster, you can get details about your SQL performance also on your supercluster. How much is the extra load the tool put by itself? Typically, I'm saying typically the highest possible load that we have seen in real world is 5%. Will depend upon the amount of data collection, number of databases running, etc. But on the very, very high end, we have seen it maximum of 5%. When you mention cloud agent, is it OEM 13C agent? No, there is a very specific OMC agent. It's a, you can think it of a cousin brother of the EM agent, basically.
There is another one related to cloud agent.
Yeah, what is the cloud agent you are mentioning? It's an agent that collects the data, very similar to the EM agent. We deploy it on the Exadata systems, where it helps you to collect the performance metrics, configuration logs, etc. So basically, it's a piece of software that goes on to the Exadata nodes.
Nice. So we still have some time, but you already answered. Okay, another one question.
Whom to reach out for demo and pricing, please? I would recommend to contact your local sales team. That can help you to provide the demo, as well as they will help you to give you a trial run for certain period of time, or by default it's about $300 that you can get a trial, which is sufficient typically for running for a month or so. But your local salesperson will be really the right person to help you with the demo and the pricing. And if you need any help on that, getting to your salesperson, please feel free to shoot me an email with your location, your company name, and little bit details about your company. I can find the salesperson for your team. My email address is my first name Ashish, my last name Agrawal at oracle.com.
No more questions.
All right. Thank you, everyone. Appreciate it, and everybody be safe. Thank you for the opportunity to the AMIA team.